Get some chips, sit down, take your pants off, get comfortable. Vic's going to take us to his College of Hacking. It's going to be fantastic. I'm going to get loaded in the dormitory right now, as a matter of fact. Ladies and gentlemen, Vic Vandal.
Vic!
Woo! Thank you.
All right, welcome to the con and to this talk. This talk is in two parts. The first part will basically be more of information gathering steps, and then the second part will be the actual, attacks against systems. This talk has a lot of things that can be used, to do illegal things. I don't condone or endorse anybody breaking the law, so I'll tell you, don't be stupid. Simple trespass can also be illegal. So and if you're trespassing on a system just to test something out, just to say, hey, I wonder if this works. I heard about this new exploit, and you just want to look at something and accidentally bring down somebody else's system. Things could turn bad fast. So get permission, and other than that, have fun. We talked about this a little bit last night. The ability to be a hacker has become a lot easier. You don't need much skills to call yourself a hacker today. There are a lot of people that are security consultants that are basically script kiddies. So because there's tools to do this, and I'm going to walk you through a lot of different tools and just doing things from the command line perspective. Today, exploits come out pretty fast. There's the talk of the zero-day exploit. Well, we've had zero-day exploits forever. They just weren't called zero-day exploits. But basically, there's a lot more people banging on systems and publishing their findings. And anybody in the world can get their hands on these exploits. The source code or executables to run these exploits are easily found on the internet. This is just one example of one place to get these kinds of things. Just touching on some attack trends, phishing. This area doesn't interest me much because I don't click on links that come to me in email from people I don't know. Spyware, adware, browser helper objects. This is a big problem on the internet. This is growing and growing. Atlanta, Earthlink said 90% of the PCs of their customers are infected. It's probably higher than that. So, if you're here and you open email attachments from people you don't know, I'll give you some cyanide at the end of this talk and push you out of your misery. Also, new trends are botnets. There's been a lot of these found. Basically, botnets. Bots are just exploited machines running code that can be manipulated from some console. The law enforcement has been shutting these down. Also, security groups have been trying to find these botnets and shut them off the head, but a lot of these are operating on encrypted channels and using authentication. They're getting a lot smarter in their creation of these botnets. And there's millions of these infected bots out there on the internet. The flood of vulnerabilities gives you, if you're an attacker, it gives you plenty of stuff to attack. This is just from one day, May 26th, last month, this year, of vulnerabilities that were disclosed. So that's a lot in one day. It's typically an average of about 20 vulnerabilities published a day.
Where's that published at?
This came from securityfocus.com. So you can go there now and find out. There's not that many that get published on the weekend, because on the weekend you guys are at places like this, but during the week, every day, you'll see a list like
Is that
this.
pretty much spread out across all platforms? I mean, I just can't see it like all of it. Just say,
Yeah, this is a lot of Linux. There is a Microsoft IE vulnerability here. There's a VNC. Actually, there's a couple of Microsoft ones. Some Perl, some links, some different apps. XPDF. There's an AIX one. HPUX. So there's a lot of Linux stuff, but there's other things as well. And it varies from day to day, you know, which ones come up. Yes?
Is that reported vulnerabilities or validated? When you say about 20 days?
These are reported vulnerabilities. Yeah.
Would they report Solaris also? I mean,
Yep.
is Solaris,
Oh, yeah.
is Solaris a lot more secure than Linux?
There's a trusted Solaris platform that is a lot more secure. I'd say Solaris it has less vulnerabilities than Linux, but Solaris has had its share of vulnerabilities as well. Every platform does. You don't see many for like mainframe systems, but there are some for those as well. The ones you don't see are the obscure platforms that typically, most people can't get their hands on. They're like B1 certified systems that the military runs for certain applications. So you don't see those vulnerabilities because nobody can access those systems and nobody can run them on their own to try and pick them apart. Okay, that was just an introduction. Here we're going to some real network, real world examples. There are some, commercial entities in these slides. They were chosen just randomly, and I'm not saying go, try some things against these organizations. Okay. So we start off, and I don't know if you guys can see these screenshots. Basically, what I could have done in this talk was sit here and run commands live against different networks, different systems. But that would have been a reliability factor and, keying in different flags and, getting the commands right. So what I did is I ran these things and I took screenshots of what I did. And I don't know how well you can see this in the back. I hope you can. Because if you can't, then you're not going to get much of what's going on. So here I took a web server, www.deere.com, which is John Deere. They make lots of lawn mowers and stuff. And I get their IP address. So that's just a simple, quick lookup. And then I go to Aaron and do a who is on that IP address. And I get Deere and Company. I get the address where I can mail stuff to them. I get their name servers, their IP addresses, and the name server DNS names. I have a phone number of a technical contact that I can call and socially engineer. And I have a technical contact email that I can send email to with malicious attachments or whatever. So here I do an NS lookup again, but I'm going to try and get more information than just getting the IP address of their web server. So I start my NS lookup command, and then I type the command set type equals any. And that's basically telling NS lookup to give me all the records that I can. And then I put in deere.com for their domain, and it dumps out more information. So I get their mail exchange servers, their host names. I get 3 different name servers, and I get the mail server IP addresses, and I get those name server IP addresses. And here I tried to do a zone transfer. So basically a zone transfer is to try and dump their entire DNS. And this used to work a lot more often in the old days before DNS manufacturers got smart and disabled zone transfers by default in a lot of their implementations. But basically, this would dump an entire DNS. So you start NS lookup, and you do an ls -d, on the domain name. And this one failed, and I just wanted to show you that, today a lot of them will fail, but some of them won't. And a lot of times what you'll get is a split DNS, a public DNS, because they're running an internal DNS that has every machine on their network, and then they're running something with their just public-facing machines. With some networks, you'll get their entire DNS. Okay, and here's a zone transfer that actually did work. So I took another domain, motorist.org, just randomly picked, did an ls-d, and the zone transfer worked. The difference between regular NSLookup and a zone transfer is the NSLookup works on, sends a UDP packet. Zone transfer will send TCP, port 53. So, firewalls that are made properly will not allow the TCP port 53 packet to connect to them, but may allow the UDP. So, so basically, I did this ls-d, and I get their name servers, I get mail exchange servers, and then I get a bunch of other servers, an admin server, a secure server, web trends, mail, www, some other one, FTP, and a lot of these are on the same address, which means it's probably a virtual IP, and you can just connect to different front ends. Then I get their start of authority record. Okay, and here's another NSLookup. On this one, I had actually, before you see this screen, I did my NSLookup, and I had gotten their name server, and I typed the command server space, and then the IP address of one of their name servers. So I attached directly to their name server, and then I typed deer.com, and it gave me some more information from their network. Okay, now going after name servers, there's a command called dig, and if you just do it doesn't run on Windows by default, but you can get versions for Windows. It does run on most Unix systems. It exists by default. So I did a dig on their domain, and it comes back and gives me their name servers. This didn't really give me anything that I didn't get from the NSLookups, but I just wanted to show this as a different way of getting this information. And it actually, what you can also do with NSLookups is you can discover other name servers that these name servers will trust. And then if you spoof that name server, you'd be able to get more information out of it. Where maybe you couldn't do a zone transfer by default, but if you spoof a trusted name server, it'll allow you to do a zone transfer. And that was some command line information gathering. Here's a GUI tool that's free that will allow you to do a lot of the same things and more. There's you got the pull down here that shows some of the things it can do. Zone transfer, SMTP relay check, scan addresses. I can't read that. That screenshot is horrible. Parse email headers, decode a URL. So if you want to do some analysis on systems, you might want to get this tool and check it out. It's called Sam Spade, by the way. Google hacking. This has gotten a lot of popularity. Google has shut down some of the searches that you used to be able to do, but you can still do a lot of other searches. Other search engines have not blocked some of the commands, like Yahoo or Jeeves or Alta Vista. One thing about Google hacking, Google indexes about 5 billion web pages, which is only 1% of the actual internet. The web actually encompasses about 500 billion pages. So, when you're doing Google hacking, you're not getting everything on the internet because Google doesn't index everything on the internet. DARPA funding has created a global web mining capability, and they have formed a product called Connotate. And it's a commercial product, and it's being sold to law enforcement, and it costs over $100,000 for this tool. Okay. Search engine hacking. What you do is search to find interesting index pages of websites. Okay.
I think your laptop just went off.
I see that.
I think got power.
The little light is blinking orange. I think it went to standby. There it goes. It's coming back. It took a nap.
Do you have your power cord?
You don't have a power cord plug.
Just don't.
That's
Requires
not my
energy.
laptop. Whose laptop is it?
It's hungry.
Who's Dell?
Go to Dell.
Needs energy quick. Is it the professors?
Whose laptop is that?
Professors, hold on.
I thought that was our con.
Here's some of your wine.
That was sitting on top of my laptop.
Gotcha.
What's the power cord?
It's a Dell.
Let's see the power cord.
There's a power cord right here. I don't know if that's.
All right, please pause for a technical.
Here, let me see it real quick.
Yeah, that's
IBM. Wait, is that the right one?
Okay, so we're back. So, you can use these search engines to find interesting websites or interesting information on websites. Here's just some operators that you can use to do your searches. File type, in anchor, in text, in title, in URL, site. You can start building some combinations to filter out things that you want and add in filtering out things you don't want and adding in things that you do want. So, like here at the bottom, anything that has a site, IBM.com, and has the strings username, user ID, employee ID, or your password is. So, if somebody gets into a front end to change their password and it brings back a screen and says, okay, here, you changed it, your password is this, I'll find it in this kind of search. And actually you can include or exclude any one of these things. If to exclude any parameters or any strings, you just put a minus sign before the field, just prefix it. So you can use the file type operator to find Excel spreadsheets or configuration files or databases. One thing that I find a lot of, or I found a lot of, is doing a file type MDB and looking for users.mdb. You'll pull a user database to log into a website, and you'll find admin accounts and passwords in there in the clear. Sometimes these Microsoft databases are encrypted. You have to have a password to open them up. There's a utility in here that's free. It'll crack that password like that. So you download this file, you try and open it, and you can't open it, you just crack the password. You open it, and you have the admin account and password, and a bunch of other accounts and passwords. Like I said before, you can combine multiple operators to get very specific in your searches. So, here I'm looking for a password in the URL. I'm looking for the words administrators, authors, users. I can search for specific web vulnerabilities. So I can search for something like powered by PHP BB 2.0.6. And I'm going to exclude any domain that's phpbb.com. And I'm going to exclude any Perl page, or phpbb.pl. Now, I've done these, you'll see these vulnerabilities being disclosed, that those, in the earlier slide, were 20 vulnerabilities a day, and you see a vulnerability in some web software, you just do a search, and it's a new vulnerability, and you search on that string, and you find 8,000 sites that are running that version of that software, or 8 million, and you know that's that many sites that if you go attack them, you have some success doing so with that vulnerability exploit. Here's one advanced search example. It's just one example of many. What I did here was I took a site, a domain, so I said site, shareit.com, then I excluded www.shareit.com. I excluded any extension that was HTML, HTM, PHP, or ASP. Now maybe I wanted to look for ASP pages, and I would include that in my search instead of exclude it. I just wanted to show these strings, and what I got here is, I didn't get www.shareit.com because I didn't want to see that. I know there are plenty of index pages out there with that. I got www.backupcd.shareit.com. So I got some other web server that they run. I got getinfo.shareit.com. So I got another one. And I got this https secure.shareit.com. So it's just an example where you can do different things. You can get creative with it. There are some tools out there for Google hacking. You can do this manually, but there are also some tools. Here's one called GooseCan. It dumps its results into a log file, and then you look at them and see what you got. Here's something called Athena. And I think what I like about Athena is it has great comments. So here, did a search of the index of secring.back. Anybody know what that is?
PGP secret ring.
Yeah, exactly. So if you have PGP, you have a public ring with your public keys, and you have your secret key ring with your secret keys. So this search found websites that have the secret ring.back page, the file that you can get to. That's pretty stupid. So, but also what I was going to say is there's some great comments here. PGP is great encryption technology, keeps secrets safe. Everyone from drug lords to the head of DEA can download it. Blah, blah, blah. I don't understand that anyone in possession, Google dorks don't understand that anyone in possession of your private key ring can get to your secret stuff, blah, blah, blah. So there are different comments for different searches. Here's Apollo, another tool. I did a search here, just in URL TS web for like terminal service web. So I got some results, and if I connect to those pages, I'll get a terminal service login front end to those servers. And you can try that, and you get the same results, and then you go to the sites, and you'll see it. Prompt you and say, enter your username and password, and maybe you guessed the right one or something.
Why would Google have indexed the terminal server service?
I mean, they're just indexing all kinds of pages that people access.
Okay.
So there are employees who are connecting to corporate systems via terminal service web link. And Google just finds that, and you can search for it, and then you connect to
You'd be
it.
amazed at on the home pages how down in the lower footer of the page you'll see admin or employee login or internet or something down, very down the way the employees know it, and you can just kind of scan the page, you'd be amazed at how many of those things you can find a prompt sheet for logins. I mean, yeah, there you go. Yeah. Not that I've seen that or done it or anything. I'm just.
Of course, me either.
Yeah. A friend of mine. Yeah, a friend of a friend.
Yeah. So I mean, you connect there, you type admin and admin for the password or something like that. See what happens. Here's another tool found StoneCloud called Site Digger. It's a little more polished. It gives you some HTML reports. This one requires a Google API license, but you sign up for it and you have it like that. It's just a key that you have to enter in here to be able to run this, because you're running a direct Google API. But this license limits you to 1,000 searches per day. Yeah, but how many of you are gonna try and it's not a you're not likely to be attacking more than 1,000 domains a day, so you should be okay. But this only works for Google. It won't work for like Alta Vista or Yahoo or whatever, so just FYI. There are other information sources for getting information on possible targets. Here's a few of them. P2P search engines. You get on Sherazade, whatever, and just start searching for like .doc or files that have secret in the name of them or whatever, and find these shared up on people's drives. You can find some interesting information.
Quicken files.
Yeah. All right, more information gathering. So, you've got some information on sites. Well, let's actually get some more information on a specific IP address. You can do port scanning with Nmap, and this is the command line. And just this IP address comes back, tells me it's a Linux 2.4, 2.5 version. It gives the uptime, which means the time since it was last patched. So if you know that Linux 2.4 had a vulnerability published on the date after its uptime or the date it was last patched, then you know that machine's vulnerable. It'll give you the ports that are open, the protocol type, TCP or UDP, and the service name, and the versions. It's not 100% reliable on the service versions and stuff, but it's pretty decent. If you're command line challenged, you can use the Nmap GUI, and you don't have to know what all the flags are. The -S, -T, blah blah blah. So you can just click the dots for the type of scan you want to do, and click scan and you go. It's just a different way to do it. Okay, scanning. You can do scanning with port spoofing. So you can use misdirection for anonymity, or maybe to frame someone else. So here's a frame script that. So basically, you take the IPs. It takes the IPs passed to it, the source and destination, and it's going to scan those ports in that first line. So you have the little frame script, then you type frame, the source and the destination, and that would basically do a scan on those ports against that IP address, and it would look like the scan's coming from Microsoft.com. So if a company has an intrusion prevention system and they detect, their customers, and you scan their system and spoof one of their customers, and their intrusion prevention system says, "Oh, we're being attacked. Shut down that network. Don't allow it to access us." You just stop those two entities from doing business together. Not that I would ever do that, but it's just one creative way that attackers might do things. Also, if you can manipulate routing tables, you can get this information back just to a spoofed address. Some IP port scanning tips. If you're trying to flesh out a network, figure out what's out there that you can check out, you're doing a pen test, just do a broadcast ICMP echo, find all the systems. Try DNS connection attempts on all hosts. The reason I say all hosts is because they'll have name servers, but there'll be some other servers that are running DNS that aren't intended to be DNS servers. Just because it came on by default, some administrator didn't turn it off. You can use firewalking to verify ports open through a firewall. I'm going to talk about that in more detail. MBT stat and net use scans for Windows host. In fact, somebody was scanning my machine back there on the Capture the Flag network on some of those NetBIOS ports. And I'm going to show you that in more detail. You send ACK packets with the source port 80 and a variety of destination ports. So, you know, there's 3 packets in the TCP handshake. You send a SYN packet, you get back a SYN ACK, and then you send back an ACK packet. So basically, if a firewall allows IP addresses to get out to port 80 to get to the web, well, if you send back ACK packets from port 80 to machines inside their network, you might get results from those scans. Send TCP ACK and UDP packets with source port 53, so most of the time they'll allow DNS lookups, so you sending back packets with a source port of 53 looks like a reply from those DNS lookups. You can set packet flags, the fin flag, the null flag. You can do a Christmas tree scan. That's all the flags turned on. You can use packet fragments and search on these popular ports.
What's the advantage of using packet fragments?
They'll evade some IDS systems.
What's an IDS system?
Intrusion detection system, because they won't know how to piece together the packet fragments to determine that there is a scan going on against your network. However, when you're using packet fragments, there are some network devices that don't play well with fragmented packets, and you may knock them out, so be careful. Send SYN packets to those popular applications, FTP, SSH, Telnet, SMTP, and web. Talked about fragments, UDP packets, run normal and reverse DNS lookups against every IP address and just see what you get back. Use banner grabbing to identify the operating system and the apps, and then you can infer the open protocols and try to attack them. Here's some network enumeration using a GUI tool, KIOPS. So you can enumerate systems, the type of system. You can see these are Cisco devices, there's some Windows machines, some BSD stuff. And this is a probable network architecture. And this basically maps this network by doing trace routes and trying to figure out the hops to all these machines and puts a nice GUI up.
So what method does it use to actually map the net? Is it strictly a trace route?
Yeah.
ICPFL?
It's trace route.
Where do you get kiosks?
It's free.
SourceForge?
Yeah. I'm not sure if it's SourceForge, but you can find it.
I always have a hard time getting a good copy of it.
Okay. Well,
I'll try to
I have a copy.
No,
Here-
you use it.
No, not that I use it. Well, you know what? I get paid to do this, so it's against some systems, not all systems. Anyway, KIOPS will also interrogate ports in the operating system, give you some more information, much like Nmap. So it doesn't just map a network, but you can look at particular services as well. All right, network enumeration from email headers. Here's an email I got from somebody at the FBI for the InfoGuard organization. Any feds in the room? Okay. So basically, you get an email and you can view headers and then kind of see hops that this email came through. It's easier on a Unix system. If you're just in mail, you just do a -H to turn on the headers. In Windows, sometimes you can look at the headers other ways. And you can find the hops that this thing came from. And so what can we learn from this email? And I've filtered out a little bit, just like who it's from, who it's to, but I can tell you it was from somebody in the FBI sending just a blanket announcement on the InfoGuard meeting. InfoGuard's a partnership between feds and commercial critical infrastructure companies. So, what do we learn here? The last hop out, the internet gateway, has the IP address of 4.21.116.10. The host name is internet.leo.gov. Their mail exchange server is mx.leo.gov. We don't have an IP address, but we might be able to get that later. It went through a host called dmzproxy.leo.gov, which has a publicly routable IP address of 4.21.116.65. If I had the laser pointer, I'd point out all these, but basically, dmzproxy.leo.gov, here's the IP address. Here's some private IP addresses. Here's the mail exchange.leo.gov.
There's a laser pointer with that as well.
It doesn't work. The battery's dead or something. So they have some private IPs. The InfoGuard.org network looks to be internal, or at least has an internal side, and some dual NIC DMZ server. The internal messaging server is 192.168.100.20. The messaging server runs iPlanet messaging server 5.2 patch 1, built August 19, 2002. So that's the last time that was updated. The sender runs Microsoft Outlook 10 on his desktop, and mine version 6.0. And if you do an errand check on the 4.21 network, it comes back and tells you that it belongs to law enforcement online, FBI, Leo, and gives you that block of addresses. Yes, leo.gov is a masked domain for the FBI. It's to throw people off the trail, although it's commonly known.
Yeah. How do you get your browser or your email client to spit this out?
When you're on a unit, it's not when you're on a Unix system. I just do a -H to turn on the headers of any email I want to look at. In Windows Outlook, I think if you click through enough buttons, you can find a place to view headers.
Yeah.
So, I mean, I can show you how I do it on my email system, but it's on the Sun OS, and probably not what you're using for email. What's that?
So you do a mail -H?
Yeah. Well, I'm doing a print of a mail message. I have a mail message number like 3. I'm doing -H. But, if you're using Pico, there'll be a menu option to turn on headers or something. So it depends on how you view your mail. Here's a somewhat different, it's a newer email from the same source, and basically it shows one thing different from the old email that I pulled those headers on. It shows IGFW, where is it? Yeah, right here, IGFW2.infograd.org. So I would guess that IGFW stands for Internet Gateway Firewall. That's just me. So you can infer things by names that you get. Here's just the second half of that header. Also what I wanted to point out here is that if you want to enumerate someone's network or find out about some machines in their network, you can send email to addresses in that network, but a fake address, just zzz at host.com. And when their mail server bounces it back to you, in that bounce message, if you look at the headers, you can see the path it took. All right, so here's an oops. Here's a Sun alert notification, vulnerability warning in their webmail. Product is iPlanet messaging server. The impact of this vulnerability, and from 2004, is that it may allow a remote unprivileged user the ability to gain unauthorized access to a webmail user's email. And the platform in effect impacts is iPlanet messaging server 5.2 for Solaris without patch 5.2. If you look back a couple of slides, they were running 5.2. Patch 1.
2002.
Yeah, they should fix that.
This is the FBI.
Yeah. Okay.
Scary.
That's part of some upfront information gathering. At this point, we're going to take a short break, and then we'll go into actual network attacks. So take a break, get some water, go pee, whatever. I've slept very little this week, and I drank way too much last night. I passed out in my room, and I woke up, Al Stroger was humping me. So, I mean, that's how trashed up.
We have pictures.
Yeah, we do. With clothes on, so. And I love Al, I was flattered, actually.
We have Photoshop too.
Oh, yes, we have Photoshop.
You don't have to Photoshop. It doesn't get any more. I love you.
I know we don't have to.
I want to have a baby. Okay, I really do, actually.
All right, so here's where we go with some actual, getting into some attacks. Here, SIPs, download Nessus. Man, you want to find out the vulnerabilities on those hosts, get it and run it.
I already know those vulnerabilities.
What's that?
I already know the folder I want in. I know exactly where I can see it. I just can't get it.
Okay. So here's a Nessus vulnerability scanner. It can, scan up against different machines. You can do vulnerability scanning manually, but it can be very, very time consuming. Nessus will do service interrogation, ports and applications that run on those ports, and then it matches the results against the database of known vulnerabilities. So if it can interrogate a service on a port and find out its version number, it has a big database of vulnerabilities and says, okay, the version is less than this, so it has all these vulnerabilities and reports it. This tool and other tools, and Nessus is free, except now if you have the free version, you have to wait at least a week before you get the latest vulnerability database updates. So they have a commercial version that they release the vulnerability updates to immediately. There are other vulnerability scanning tools. Some are free, some of them don't do as good of a job. Some of them are commercial and do a better job. Nessus and the other tools can take credentials, so you can use plug in some login credentials for a domain, say, and get better results. Having some authentication to the machine for scanning. The better commercial tools will check the service results. They'll also use remote registry scans and actually remote file scans to get more information about the vulnerabilities and correlate that information and do a better job of not reporting false positives. So I personally, the Harris Stat Scanner does the best job of eliminating false positives because it does a pretty good job of correlation of information.
What was that?
Harris Stat Scanner. Yeah. Harris is a huge organization, but their stat scanner is not too well known. From a false positive standpoint, I'll take it over any ISS or Retina is a piece of trash. If anybody's thinking about buying that piece piece of shit don't. EI scanner.
Tell us how you really feel on that one.
Yeah. Well, I haven't done thorough analysis of vulnerability scanners more than once. So once you find these vulnerabilities, successfully exploiting them is trivial because you can find the freaking source code or the executables to go exploit those vulnerabilities and you run it and you're in.
What is the law about running a scan like this?
Typically, you can scan somebody's system as long as somebody's network, as long as you don't do a denial of service on doing that scan.
Right.
There are smart scanning options and there are dangerous scanning options. So, if you DOS somebody's network, that's your ass.
Yeah.
As far as the law on actually, trying to attack a system, in some states you can't trespass. You can't, log in with a.
But I wondered just doing the scan because they can see where the scan's coming from, usually if you
Right.
spoop it. And so if they're going to come back and say, what were you doing scanning this?
It's not really a legal deal. What the most of them do is contact your ISP and say, this guy is
Doing,
attacking me, and let the ISP deal with it, maybe revoking your service account.
right.
Yeah.
And laws vary from state to state. I mean, there are federal laws, there are state laws, and
Yeah, well, he just answered it, but I mean, I know the answer to it, but, about the ISPs who don't care, who are probably like pretty much, that's what they're doing. They're just hiding people, and that's all they do. Is there really any legal forms at all? I mean, does that mean for like, known ISPs, that basically you go out and do a search and you find out people for like years been talking about this block that's hosted by whoever is known to hold hackers, and that's all they do is pretty much just scan. And that's all they do. But I mean, it's really no legal thing. I mean, there's nothing. It's just
unless
one
those
two is so legal.
unless those scans are causing denial of service.
So that falls right. Okay.
I mean, you can look at Google indexing as some kind of scan. I mean,
Right.
there are plenty of things you can determine as a scan. There are applications that just are misconfigured and go try and find machines they can connect to, and they're scanning. It's not even a person.
So when it's obvious coming from like a block, I mean, there's like several IP. It's just like you just said. It's not illegal, but even though it's obviously wouldn't what it's doing, but they don't care. They're not going to pursue it.
Yeah, they're not. So when you're scanning, one thing I would scan for are bind vulnerabilities. There's been a lot of bind issues. It's the most widely used DNS package. So that makes it a good target to try and exploit. It mentions in here, this is one of the top 10 internet vulnerabilities from the SANS list. A lot of times it runs needlessly on systems. It shouldn't be providing DNS servers, and maybe the admins installed it by default. Some vulnerabilities can cause bind to crash, like the Z transfer problem. And being that DNS is critical to most network connections, potential damage from bind vulnerabilities can be high. You take out some core DNS servers with bind vulnerability, and suddenly you've crashed a big part of the internet. I'm not going to go too much into that because I know Matt, yeah, I'm trying to think if he's talking under his handle or his name. He's doing a DNS talk later, so I'm sure he'll go into some more. So, say you find a bind vulnerability, and basically in my testing, I found a machine that had a bind vulnerability. And I ran an exploit, and it gave me a remote shell. So I compiled this exploit prior to running this command. This one was from a failure to properly validate NXT records, and it caused a buffer overflow, and you execute arbitrary code. And this one gave a remote shell. So I just ran the exploit against that IP address with those two factors in it. And if you run the exploit, and you can find the source code, if you just name the exploit without anything, it'll tell you what you need to give to it to make the exploit go. And I did, and ran it, and boom, it put me here, and I type ID, and it's your root. So if you're exploit or bind or any vulnerability, what can happen next? Here it is at the top, 4 commands in succession, with a semicolon, just string together. CD to slash, ran a uname, print working directory, and ran the ID. So it shows the root here. So what might you do with this root shell? Well, here I create 2 accounts. Gene Simmons from KISS and Paul Stanley from KISS. So I create the first account and I make his ID number 506. And here's his password. And then I create Paul Stanley and I make him a root account because I'm root. So I put him in the Etsy password, I put his shell, and I put him in the Etsy shadow. So then I secure shell. I exit out. I'm done. So then I SSH over to that exploited machine, and I log in with the first account, ID 506, and it tells me no home directory because I didn't do the add user command, which would have created the home directory. So it gives me that error, and then I SU over to Paul Stanley, and now I'm in this root. Now, why did I create 2 accounts and log in with one and then SU to the other? Yeah, most systems you cannot SSH directly in this root, so you have to come in with a non-privileged account and then SU over the privileged account.
So why'd you pick Paul Stanley instead of James?
Because, he's the star child, and, he sings more of the songs. He's prettier than James. I don't know.
He comes longer. The other way around.
Okay, net BIOS scanning. Basically, what you're doing here is trying to find, when people create Windows shares, the default permissions is everyone, full control. So, there are tons of shares in corporate networks and on people's home machines, and basically anyone can connect to them and copy whatever on the share in the folders. So you do NetBIOS scanning. It's UDP ports 137, 138, TCP port 139, and you're basically finding shares. Here's a GUI tool to do it. I'm going to show you some command lines stuff to do it as well. Here's a different tool, and it shows open shares, it shows IP addresses, it shows MAC addresses, it shows the OS type. That's that same tool. There's more information that you can use to pull out of it. Users, groups, local security policies. A free tool that I recommend to get the same kind of information is DumpSec. So I know somebody said there's some shares on that machine back there that are open. I know the IPC dollar is there because it's an admin share that's on every Windows machine. But if you want to try and attack something from a share perspective, right now, download DumpSec and see what you get. And that's not what I was going to get to, Seth.
According to Microsoft, all NetBIOS is taken out of 2K3 at this point. Is that true, false?
It's not true, because it's Windows file sharing, and if they took it out of Windows 2K3, large enterprises are built on using Windows file sharing. There's no way they could take it.
Yeah, I just know what I know what I got to know for the certification.
Okay. Anyway. So here's a NetBIOS 2-minute hack. Okay, here's a quick hack. This was me at work. on the GE network. So we'll just do an IP config. My IP address was that, that day. That's not my IP address anymore. Anyway, so I do an NBT scan, and NBT scan is a tool that anybody can get for free. And I scan a short range of IP addresses. I'm 25. I want from 10 to 20. And I'm going to put the results in NBT hours.txt. So I view the results of NBT hours.txt. This is at work. You can do this over the internet. There are people that have open shares all over the internet. So I get some machines, some IP addresses. And I could have scanned the entire network, but that's my results. And so I got 2 minutes to do this hack, so to speak. So I'm going to, I've done my MBT scan, I've looked at my results, so I'm going to use the net view command to find specific share names on a machine. So I do net view, pick one of the IP addresses from the former slide, and this was a manager at work, and I get these 3 shares. Okay? So, okay, this manager's got these 3 shares. You use net use to mount net use. I put the drive letter that I want to map the share as, V for Vic, and I put the IP address, and I pick the share name, Bob's Drive. And then I open up Windows Explorer. Here he is. So, I'm not going to show you the contents of Bob's Drive, but, that's how quick you can do an NetBIOS hack. Okay, so you'll find tons of shares if you use it NetBIOS scanning and mounting shares. Suppose you don't find a useful share, you can go after the IPC dollar share. So suppose that people just didn't share any drives on these machines. So you want to look at the folders on this machine. IPC dollar it's not, it isn't a share in the sense that it's a directory. It's an admin share. It's created by default when the system's booted, and IPC stands for Inter-Process Communications, and basically it provides the capability for logging into the system. So, did a net use, IPC address, the IP address and IPC dollar. If you're a domain admin, you're going to, those credentials get passed and you're into that machine. Say you're not a domain admin, so you do this command, net use, the IP address, IPC dollar, user administrator, and if the administrator account has no password, it'll get you in. Or you can use this command and send the administrator account into some password. Because to get an IPC dollar, you have to be an administrator. You're not going to get in as a normal user. So this is the only way to attack that. And this, you're attacking this because there are no other shares, and you want to try and get to the shares. So, C drive isn't shared, but you can get to the C dollar share. And if you can log in with this, if you can make this work, then you use this command, and you've got that C dollar shared mounted. So what do you do now? Access any data. You can run regedit, connect to the network registry, type the address of the target machine, and you're in. You can copy the SAM data and crack account passwords. So you can't copy the SAM file directly, but there's in the repair directory, there's a copy of the SAM file. So you can copy this. If you run rdisk/s first, it'll dump all the current account data into the SAM file. So if you got the SAM file, then you expand it, run it through SAM dump to put it in a format that you can use password cracker, SAM dump, SAM, and put it out to the SAM file. And now you can use Lockpick or NT-Crack or whatever to crack those passwords. What else can you do? Copy remote.exe to the target system. So remote.exe came with the MT resource kit. It comes with all the Windows resource kits. It's gotten a little more security into it over the years, but not much. So its initial versions had no authentication whatsoever. So if you had remote.exe running on a target machine and remote.exe running on the client, you just connect from one to the other. There's no password, nothing, you're in. Nowadays, most remote EXEs, you have to create a password when you run it. So if you know the password of the machine you're trying to connect to, using the remote EXE as a client, you're in. So you can remotely start the scheduler using the scheduler command. Check the time. Start remote EXE a few minutes later, but doing this command. So if it's 7, I'm going to at 7:05, I'm going to start it, and I'm going to start remote EXE, put the password as secret, and then I use remote EXE on my client system to connect to it on the target server. I type in this command, and I'm in. So once I'm in, what am I going to do? Whatever. And when I want to quit, @Q will quit the client without killing the server, and @K will kill the server. Alright, so if you want to attack shares and you don't want to sit there and type commands to guess the administrator password, here's a script, Perl script to automate that attack. Basically, it'll take words from a text file and try to connect to the IPC dollar with every one of those as the administrative password. So it's an automated dictionary attack. And here's a script to do that. Windows accounts and passwords. If you're trying to get to, well, this talks about vulnerabilities and landman. So basically, any password that's 14 characters or less gets stored as a landman hash along with the SAM. And the landman hash gets stored in 2 7-character chunks. So basically, if you have a 14-character password, you really have 2 7-character passwords. And when you run the cracking utility, that's all you're trying to crack is a 7-character password. And it's easy to crack if you have those landman hashes. If you crack an account, a domain account, yes?
If you're AD, does this SAM stuff apply? This is only cracking a workstation, right? The
SAM file, in a domain exists. I mean, it'll exist on every machine. And in AD, there's the database of account passwords.
Okay.
And every machine will have a local.
But like, if it's Active Directory, will it be just like one, like administrator only in there?
No, I mean, the Active Directory doesn't even have an administrator account per se. I'm not sure, but
Yeah.
I think that they would all be there.
The stuff I learned from the certification is driving.
Okay, so
I'm certified for this. How to find that?
in a domain, if you get one account, so if you get a domain account, you can use it to log on to other resources in that domain that account has access to. If you get a domain admin account, it's game over. You get everything. Or an enterprise, domain admin or an enterprise admin account. If you create passwords that are more than 14 characters, it'll store a null value as the landman hash. which means there is no vulnerability. However, through native Windows group policy objects or local security policy or domain policy, the biggest you can make a password is 14 characters. It's created that way to support the landman hash. However, you can use a passfilter.dll to set your own specific, stronger password policies. If you want to mitigate that kind of vulnerability.
There's actually a rainbow table hack for LAN manager that can crack the extremely random passwords in a matter of, like 4 passwords in a matter of like 4 or 5 minutes.
Yeah.
Extremely random.
Yeah, and I've cracked passwords really fast as well. So, and yeah, like I said, you get, even if you don't get a domain administrator, each server or each workstation has a local administrator account. In an organization, what's the likelihood that whoever's building these servers or building these workstations isn't going to make each workstation or server have a unique password? So if you get one machine, because there's one vulnerability on one server or one workstation that's not patched, and you remotely exploit it and get that SAM file and crack it, you can use that to get local. You don't need domain. You can get that local administrator account on every machine. You were going to say something, Nick? Or?
No, that's totally right. That SAM file exists on every machine or domain, so all it takes is one machine and you're done. All the SAM files out there.
Right. Yeah. If you're a desktop support guy and you could have to go support 500 users, you're not going to remember 500 different admin passwords. You're going to use one organizational admin password. So you get it off of one machine and you go. So how do you obtain Windows passwords? And I think Strider A was asking you this because there's some tasks they have to go attack somebody else, get their administrator account. And here's actually, say the password hashes are in the primary domain controller. So you can dump them from the primary domain controller if you're the administrator. You can extract the SAM hashes with pw dump, any version, or SAM dump, or whatever. Get a copy from the WinNT repair backup directory or any emergency repair disk. Or if you have physical access to the system, you can boot into another operating system off CD and copy the SAM. Or you can sniff those hashes as they travel over the network. Yes?
Is the SAM the repair? Is that when is that dump like every time it shuts down? When is that like updated?
It's not updated often. I can't remember what the mechanism is that makes it update, but if you run that command that
that's what you're talking about, right?
Yeah.
Okay. I didn't know if it was just like when you
I
shut
can't
down,
remember
it
what the
updates it or-
trigger is that makes it, but it's not, it's not every time you add an account or every time a machine's booted.
You have to do it manually.
Oh, really?
I got the command word standard.
So, cracking the Windows account passwords. Here's a GUI tool to do it, or OPH crack. Not my favorite tool at all. This is actually my favorite tool, Kane. Kane Enable. It does a lot more than crack passwords. I don't have a slide showing all the different things it does, but you can use this to, like I said, if you pulled one of those MDB files, you could use this to crack each password. And it can be Cisco device enable passwords. It could be landman hashes. Here's just a dial-up config file. And basically, this config file had an encrypted password, and this isn't my real password. I just did this for demonstration purposes. I made my password for this dial-up connection, my test password, close it. And here it is, it's cracked. And it'll crack pretty damn quick. And this is freeware, so if you don't have it, you should get it. Check it out. Sorry about elevating Windows privileges. This is just an old example. It only works on Windows NT, but there are a lot of Windows NT machines out there. So suppose you have an account on a Windows NT box and you want to be an administrator. There's a tool called, an exploit called getAdmin. So what it'll do is add a normal user to a local administrators group.
Does it ask for a password?
Nope, no, it exploits a vulnerability. It can be run from any user context except guest, which it attaches to WinLogin, which runs as in the system service account, and it makes an API call to add the user to the administrator group. And you just run it from DOS, getadmin.exe. And there are a lot of other ways to elevate privileges by exploiting unpatched vulnerabilities or bad configurations or poorly designed code. We'll talk about some of those in other slides. This is another privilege elevation example. This isn't the entire code for this program. It just wouldn't fit on a single slide, and I didn't know. But you can find this code. It's called lowpriv.c. And basically it leverages the service account privileges to provide local account greater access, and it exploits vulnerability with name pipes between a SQL database and the operating system. Okay, cracking Unix password. You can use dictionary and hybrid attacks using the crack utility. It has an API, so that's the name of it. I'm sure some of you have heard of it. You can integrate crypt functions in different password file formats. That's how you run it, crack space / etc shadow. And then there's a reporter script that you run to see the results down there. It creates HTML output. And the quiet mode will suppress any errors from being reported. And it has other flags and features. So if you obtain anybody's Etsy shadow file through a Google search or whatever, you can run crack against it and see if you can get in.
How does a crack utility know it's got cracked? I mean, it could decrypt it to eggs or ham or salad. I mean, how would it know when it's decrypted?
It verifies the
it's
encrypted with a hash.
Right,
Oh,
it's hashing things and then matching the hashes. SNMP scanning, there's a tool called 161, and this was just a quick little run I did of it. Today there's a lot of it, SNMP enabled devices, because a lot of organizations are doing enterprise management, desktops and servers. And it's just something not to overlook if you're doing some pen testing. Here's an SNMP vulnerability, just one of many identified on various platforms over the years. This one allows both remote and local execution of arbitrary commands. And so you got the vulnerability. Well, I need an exploit. Well, here's the exploit. Here's the code. So it's not hard to crack in the system. This one I tested against only Red Hat version 9, kernel 2.4, and it worked. It gives you a reverse shell backdoor. Okay. Why didn't exploit the hard way? So there are GUI tools that you can point and click and run exploits. Suppose you don't have one of those GUI tools. Well, this isn't really the hard way. Basically, you're a Windows geek, you don't know anything about Unix, you don't have a C compiler. You can download this C compiler. It's a free one, it's very good. To run it, you just run the, double click the executable that you download, this LCC 132. So after you've downloaded it, you run it against your exploit code. So I have that SNMP exploit code that I grabbed from that former slide. I run lcc.exe on snmp pd exploit.c. The compiler creates the executable, and then I run it against this host. Run it. I'm done. ID through. That's how, you know, hard it is to explain a system, you know, with source code. Compile it, execute it, you're in. I need a little more water. Excuse me 1 second.
That's water. Water.
Yeah. I'll survive through this. Okay, so here I want to try and exploit Samba vulnerabilities. It's a tool called FLAK, P-H-L-A-K. Samba is basically the Unix version of doing file shares over the network. It also uses port 445. This was just a run of FLAK and getting results. Say you get an Apache vulnerability. This is just one example of using Metasploit. I'm sure some of you have heard of Metasploit, some of you haven't. This is from an older version of Metasploit, so it doesn't have all the payloads that you can get today. And with Metasploit, you can run it in command line mode, you can run it in GUI mode. I didn't show the GUI mode here just on purpose, but GUI mode is super simple. Puts you up a GUI window, you type in the IP address and click go, you know, you pick your payload, you attack the system. So here I showed the exploits in this Metasploit framework, and I want to use the Apache chunked Win32 exploit. So this is the command I type. And then I type show options, and it gives me my exploit options. Then I set the host I want to attack. Remote host is that IP address. Then I type show payloads, and so I'm going to exploit this vulnerability. Well, what am I going to do once I've exploited it? What payload am I going to dump in there? Different ones I can use. They do different things. So I set the payload to use the Win32 reverse shell, and then I typed exploit. So I've set it all up to do what I want it to do, and then I run it, and I get the reverse shell connection. And basically, a reverse shell is, it starts I have to be running a listener on my client machine, and from the target machine, it connects back to me. Microsoft IIS vulnerability. Here did a command line to interrogate the service to check media on the IP address. It tells me what's running Microsoft IIS 5.0. I've already compiled an exploit called NSIIS log. I ran it here without arguments, and it gives me my syntax back. This is run it with the IP address, and you can specify ports, and then you just run it, and boom, it does a buffer overflow and creates a remote shell. And you know what? I bet you something like that would work in that machine back there. Remote shells, so many attack payloads incorporate the opening of a remote command shell. And once you have a command shell, you do whatever you want. Basically, it spawns a process, pipes the output through a network socket, and you can do it as a covert channel if the exploited process runs as Unix system, which basically means it won't show up as a running daemon or service. So it's covert in that way. So what happens after you get your shell? Anything you want. You can kill the syslog D or event monitoring. You can download and install a rootkit or a netcat backdoor. You can store a password to access Trojan programs. You can install a Trojan login process. You can hide your installed files and processes. Replace any system utilities that might detect backdoors with filtered versions. So you can just system commands and just make sure that they don't show your processes. Install a sniffer, install a log cleaner, enable other services that you might want to use, restart services, restart your logging process, deface a website, manipulate data, attack other systems, whatever. How do you do it? It varies from, how do you do it specifically? How do you install a log cleaner? It varies from system to system. And there are various code examples. And rootkits will include all or most of these things in one small kit. Here's a drive-by web defacement. This screenshot comes from an already exploited host, but and actually this was just on the box itself, but you can get the same directory listing through a remote shell. It's just showing you there's a Apache directory structure. From the previous slide, I wanted to go into htdocs, so you got the index file. And I'm just going to use trivial FTP to download new content, which is just a new index file. And then I've got, a new defaced website. And if somebody was running a sniffer, this might show what that exploit looks like, or that defacement looks like from a forensic IDS perspective. So first you have to delete the existing index.html using the delete /f command. And so you see the system connecting to the target and deleting that file. And then you use trivial FTP via reverse shell to get the new index file. That's it. All right, netcat utility. So let's get interactive. If you use trivial FTP to copy netcat to a remote system, then you can create a little bat file, and that file will run netcat. And this command nc-l-d -p 2002 -e command.exe. It starts a command prompt or a shell listening on port 2002. Then you check the scheduler, you start the scheduler, you schedule this netcat backdoor to run at a certain time, and then you use the netcat client to go connect to that exploited server on that port. And from there you can do commands, file transfers, whatever. So we're going to show you something about netcat. And that capture the flag box right there.
Isn't there also netcat for Linux?
Yeah, netcat runs on either. I don't know if you can see this, but here I use netcat to do a port scan. Netcat -v -w2. Thanks, man. -z 10.10.0.2, which is that capture the flag host. And I just ran ports 1 to 100. Okay. So this shows a little bit of the flexibility of netcat. I can use it as a port scanner. I can use it to interrogate services. I can use it as a remote shell. I can use it to transfer files back and forth. So I used it as a port scanner, And I got port 80's open, port 25 is open, port 21, 19, 17, 13, 9, 7. All right? So then I want to interrogate port 80. So I run netcat -v -n 10.10.0.2 port 80. Comes back IS5. I happen to know that there's a Unicode file traversal vulnerability in that software. So here's the meat, guys. And I run netcat -v -n 10.10.0.2.80. Boom. Then I run get the IP address /script /./%255 WinNT system32 command execute directory, and I get a directory list off that machine. What else could I have done with that command? I could have run trivial FTP to download netcat from my machine to that machine. Then I could have started it using the scheduler. Then I could have connected to that machine over that netcat pipe and grabbed the flag file, edit it, copy it right back. Flag is mine. That's how easy. And you can do all of that with the netcat utility. One utility does it all, if you know how to use it. So could I have had that flag today? Yes.
You can have anybody's flag.
All right. Back to the show. All right, what's going on here? What the hell is this, man? Sips, were you paying attention? Was Sips even in here? There he is. Sips, did you pay attention? Did you see that, Sips?
No, honestly, I didn't.
Meanwhile, he just used it to get.
I was upstairs getting my laptop.
Yeah, okay.
I can see that, I just can't change the flag.
I wish I had photographic memory now.
All right. Session hijacking. Anyway, get netcat, learn how to use it. Session hijacking, mainly executed against Unix system, involves IP spoofing, ICMP redirection, and sequence number prediction. Insert source routed commands into an active connection between two nodes, impersonating one of them. And T-Dub was talking about some of this ARP spoofing today. And I'll just say check out these tools if you want to try some session hijacking. So basically just you can view these sessions going on and click the one you want to hijack. Hunt, Juggernaut, Ettercap, which I think T-Dub was talking about specifically. TTY Watcher, DSNF. So that's all I'm going to say about session hijacking. Buffer overflows and overruns. T-Croc was talking about this. Made possible by coding languages that don't do array of bounds checking in the runtime environment. And basically, it's when an application takes data and copies it to a buffer without regard for the buffer size. And it's a lack of input validation. And so in case a function that has a buffer on the stack, the function's return address is placed in memory after the buffer. And so an attacker can make his own return address for the function by overflowing the buffer and overwriting the return address and get the instruction pointer to 22 his buffer, or the user-controlled buffer. On buffer overflows, the attack payload is not the same as the entry point. So this is like a missile system that delivers a warhead. Take the Morris worm. It was deployed via buffer overflow in finger D. So that was its injection vector, and then it exploited it to open a network shell socket to deliver files that would try to propagate the worm to other hosts. And it used two different methods to do it. So, not going to go deep into buffer overflows, but writing buffer overflows attacks, it's not trivial. When you're trying to do this, you can easily have your injection vector and the payload clobber each other in the same buffer, and it doesn't work. The stack size limits constrain an attacker to tight coding and small data payloads, which I think I mentioned last night. You can try to put part of the payload on the stack and part of it on the heap to get a little more leverage. If you send a null character or other bad characters inject in your exploit, it goes on the wrong place on the stack, it would cause the stack to stop writing, which means the overflow won't work. And just guessing randomly where to go, likely not landing in the right place. Payload's not going to execute. Software or the service could crash, meaning the host could go down. So you're trying to attack some RPC service buffer overflow and take the host down. Then you can't attack it anymore. It's down, and they're going to wonder why it's down on that machine. So one technique for finding a good payload address is to use NOP, which is single byte instruction, and basically you just fill the buffer with NOPs because it's a small single byte instruction. It is a sled till you get to the right payload execution. Firewall circumvention. Basically, this is exploit tree from Metasploit, and it shows different firewalls that have exploit code payloads in them. So here's Checkpoint. Here's a few different exploits. A lot of commercial firewalls have vulnerabilities in them. So if you're trying to bypass a firewall, exploit a vulnerability in the firewall and then use it to open whatever port you want and get through. Just take it out of the picture. Gauntlet picks, or Cisco picks. How many organizations use Cisco picks as a freaking firewall? A lot. Raptor, Cygate, Symantec, which actually Symantec bought Cygate, which means they'll fuck it up. A good product. Zone alarm.
What is that directory listing from? Metasploit.
Yeah. Yeah, if you install Metasploit, you can go down into it and find a lot of different payloads. Other firewall circumvention. And you can see if it blocks TCP, UDP, it allows ping through. So you can use a trace route -L. Might be a capital I don't remember. But it would use ICP instead of UDP. So a lot of firewalls will allow DNS through. So port 53. You can trace route towards an internal host. So and see where it's blocked. And where it's blocked is going to be the firewall. So trace route, and in this example here, I'm just using 6 hops to the firewall. Trace route increments a port by 1 each time it's used. So we take 53, port 53, which is DNS, subtract 6 times 3, which is 18, plus subtracting 1 more. So 6 is the number of good hops noted, and it was 3 packets sent.
Could you speak up a little bit for us back here, please?
Oh, I'm sorry. Okay, so you end up at 34. So you issue a trace route -P 34 to the target IP. when it hits the firewall, it will be on port 53, and then it will pass, if allowed, to the internal target. And for successive probes, because it increments it by 1 each time, you want to use this command, -S, -P34, to keep the firewall port at 53. So this method can be used with other ports and protocols for firewall filter testing. And you can do this, make it better using the firewalk tool. It will do that back-end scanning. So basically, firewalk -N, -P1 to 7, -P TCP firewall IP, the firewall IP address, and then the target IP. So basically, firewalk will bind itself to the firewall and then try and scan the target machine on the inside of the network on a slew of TCP ports. It'll do a full TCP port scan on that target IP behind the firewall. And then you'll get responses received on all the protocols that are allowed through the firewall to that target. And it can perform UDP scans as well as TCP. And has other features to improve its results. It won't work against pure proxy-based firewalls because proxies don't forward packets, but it works against packet filtering firewalls, which most are, Cisco picks. So you can get that tool. It's just a modified version of Traceroute that kind of automates the scanning process, which you could also do manually. Okay, firewall reverse tunnel. There's a tool called that command. It's a client-server utility, and basically, we talked about the TCP handshake where you have a SYN packet, then a SYN ACK, and then an ACK. So most scans are based on trying to send a SYN packet because that's the way TCP works, to set up a session. You have to send a SYN packet, and firewalls will block inbound SYN packets, but they'll allow ACK packets through because they assume that a client has made a connection out to some server on the internet and the ACK packet's coming back. It's not an inbound connection if it's an ACK packet. It's something that's just a reply to a session going out. Yes?
Doesn't stateful take care of that? Stateful inspection?
Yeah, if you have a firewall that it uses stateful packet inspection and it's turned on.
Pix does that? You
can do it with Pix.
But you don't normally?
It depends on who the admin is and how they're configured. So basically this will allow you to connect to a machine just using ACK packets. You never have to send a SYN packet to the ACK command listener. So if you deliver this Trojan to somebody via email, then you just use it to go connect to that same utility and you get a remote command prompt. And to make this proxy enabled, it's not that hard, if you're a smart person. So I said, abandon all hope when you enter here, because this is could be bad for a lot of organizations. Suppose you're encountering IDS, intrusion detection system. My phone's going dead. Does anybody have a time check? 5 o'clock. 5 o'clock. Okay, so you want to do IDS detection. There's a tool called Stick. Stick will generate a flood of packets built randomly from actual snort attack signatures. So it just drives the IDS system nuts because it's like a million attacks coming at it. And it just basically causes a meltdown. These IS Test Real Secure, Snort, a bunch of other IDS tools completely overwhelmed, and they just die. And there's so much junk being thrown with spoofed addresses and everything else. There's no way you can find out who's really attacking you. There's other tools that can fuse or disable IDS, frag route, and snot, which is obviously a variation on the word snort. Okay, so suppose the lobby's locked, the front door is real shut tight. This just goes to show there are other avenues into a network. Use THC, the hacker's choice. Actually, this is phone suite. Try and connect through dial-up. David Lightman did this in 1983, the Newly War Games, and it still works today. There are still plenty of organizations that have dial-up modems, and you can use utilities to try and connect the systems there. Once you get in, you hop around their network. And I like the freeware tool THC, which is the hacker's choice.
THC?
Yeah. Not as in marijuana, I like that too. But yeah, it's the hacker's choice. And new side door, it's not that new anymore, wireless. This is Kismet. It's brainless to use, takes no skill whatsoever. I took Elvin and some kids war dialing a couple of years ago here. It took 2 minutes to start and just find SSIDs.
And then your laptop died.
Yeah.
After those 2
Well,
minutes.
I didn't have the power to it. My battery was almost dead. So suppose you find a wireless AP that's using the web, which you find a lot that aren't. They're totally non-secured. You want to get the web key. You use web attack. Here I just showed the commands just to install web attack. I untarred it, CD'd into it. I did a make, then I did a make install, and boom, I had web attack. And then here I ran web attack, InfoSec, took a Kismet dump, and ran through a word list. And you just basically try and crack that web key using web attack. You can install John also and combine web attack. You can configure web attack to use the John word list and improve your results, attack results, getting the web key. And there's this GUI tool, Aircrack. It's pretty fast algorithm for brute force attacks. It runs on Windows or Linux. Fast can be a relative term depending on the strength of the web key. I mean, I've run this against a web, trying to get a web key like 5 days straight to get a key. Other kinds of attacks, denial of service attack. Windows registry tweaks and Unix configs. We're trying to minimize that impact. Here's a SYN flood. Basically the same kind of deal as a Smurf attack, except it's a SYN flood instead of an ICP. Distributed denial of service. Who does this? Angry young men and explosions, in my opinion. This was just something that had a little levity, but I've known people that perpetrated distributed denial of service attacks. I see no value in doing this. It's just a malicious mindless thing. People will extort money from companies today. And they'll use bots to take companies down. They'll say, "Hey, send me $1 million to this address in some country in the Middle East, or we're going to take down your network." Here's just some commercial spyware products. So what I'm showing here is, you don't have to always write your own little Trojan or have some obscure software to get information off of somebody's machine. There are companies that commercially sell these products. There's dozens of them. These commercial products with captured passwords, email, chat, web pages. The activity is automatically sent off-site. Costs between $50 and $100. Here's a couple of them: Ace Spy, Competitor Spy. Here's some more. How they get deployed. You can deploy them physically. If you have physical access to a machine, just install them. You can send them via an innocuous-looking email attachment or hack a machine. Obviously, this is illegal, but these companies sell these tools to people and corporate espionage, interested persons, and they get used. And hey, I know we're hitting short on time, so I think I'm going to wrap up in like 2 slides, actually. Okay. Here's a Hackers Complete Toolkit Auditor. I know some of you have heard of it, some of you haven't. It's a bootable distro, has lots of hacking, cracking, information gathering tools. Here's just a screenshot. It's free. You can do footprinting, scanning, spoofing, hit Bluetooth, wireless, brute force, password cracker, forensics, honeypot. These different scanners, like a big scanner here, a security scanner, a web server scanner, network scanner, whatever, SMB scanner. From here, I have a selection of a few different ones. You can also install Auditor to your hard drive.
Somebody have a copy of that here?
I do. I have a few copies of it. Here's what I call Auditor on Crack. This is Backtrack. It's kind of new. And you can download this from,
I got 150.
you can download Auditor or Backtrack from remote-exploit.org. It's free.
I don't really want to get caught downloading that. That's my home PC.
Well, I get paid to do this, so I've got all kinds of tools. My workstation at work got confiscated in an investigation last year. And I didn't do anything, but something bad happened in the network, and it's like, who's the most likely suspect? Oh, Vic, let's take his machine. So anyway, they send it to some FBI lab, and when the CTO asked for this machine back, they tell him, man, he's got all kinds of malware and hacking tools, and refers into virus code, and it's like, yeah, that's what he does here. That's what we pay him to do. So. That's all legit. And all those viruses came from the CTO, who sent them to me for like reverse engineering. But anyway, so as a security profession, you should have these tools. You should know how to use these tools. You should not worry about downloading them. So Backtrack, it combines wax and Auditor and throws some Lockpicks in. Provides user modularity. It can be customized to use personal scripts or additional tools or customized programs.
One quick question. Why do you like Backtrack over Auditor?
Well, you know what? I actually don't. It's not as user-friendly in my opinion, but it is more flexible. You can, like I said, integrate things that you can't with Auditor. So it's got those APIs. And that being said, I've gone through 98 slides, and we've covered a big gamut. And in here I was going to go into some web attacks, but we're because of time we're going to just stop here. But basically, it talks about why web applications are so easy to attack. What can you do through web attacks? A lot of different things to get information. There's input validation problems. That's the heart of all security problems. This is Hello World, and there's basically a cross-site scripting vulnerability in every Hello World implementation. There's default CGI vulnerabilities in a lot of different web server software. I saw one last week, some CGI vulnerability. Basically, you see the exploit, and you just do your Google search on, powered by whatever, and you get in. And here was just showing one vulnerability with the default included CGI. And plenty of websites get hacked because of bad CGI code, and whether it's a default CGI script or a user-coded CGI script. So there's Campus. There's one in A Glimpse, and here's showing the exploit of it. Hey, Steve, Computer Associates. Gee, I hit this site, and what kind of error do I get then? Login failed. Okay, what does that tell me? Anyway. And here's just this was simple, just threw in a little SQL injection, and instead of getting, one result, I got 36,000 results in the search. I've seen applications where you throw shit in like this, and it bypasses the authentication complete that you're in. Here's a tool for SQL injection called Absent. Now, honestly, forget most of those lessons. One doesn't have to do all this hacking today, and the paradigm of hacking is switching. So if I want to attack some organization, I'm going to get a list of employee email addresses, like clearing the mail exchange server, or using one of my names directory or whatever, and then I'm going to pay some underground coder to write me a new executable that's unknown to antivirus software, and I'm going to email it to every person in that organization. And some percentage of them are going to open it and run it, and it's going to install code on the machine and start sending out everything in the network and open back those. So the paradigm of hacking is shifting. And I'm not suggesting anybody do that, but there was actually there was a targeted attack like this publicized a few weeks ago, where an organization, there was a piece of malware that targeted a specific organization in some kind of corporate espionage. So, what have we learned? It says, hey, this is your computer. Since I see everything in the room, I thought I'd throw you a few pointers. First, put on a shirt. Second, you got a nice girl lying there on your bed, and you're sitting there looking like a goon on the computer. Come on, dude, don't be gay. So, anyway,
my computer.
What I'm saying, don't get caught up too much. Don't be such a geek that you ignore your girlfriend. But, what have we really learned? If you're a sysadmin, hey, it looks like you're responsible for network security. You just saw how easy it is to, exploit it.
That is the best thing I've seen that tool used for.
Don't kill yourself.
They make games
So,
out of different ways to kill clip.
I have these slides where I talk about incident response and incident recovery. And I talk about some of these attacks and some risk mitigation strategies. And all these different kinds of attacks, I've talked about mitigation strategies for them. And if you're a sysadmin responsible for your network security, you should know about the attacks. You should know thy enemy, and you should know how to, prevent thy enemy from kicking your ass.
More than 2 slides.
All right, man. So this is the. Any questions?
Back up there.
Any questions? Yes.
Okay, you're saying about the email coming in. One was to put like a squirrel mail server up, so it all got run and kicked out as HTML. Then you put the OS on a SAN every hour or twice an hour. You get a snap. They see it's a snap change, so your data would be on something else. The snap's changed, then roll back and reboot. So hence they can't modify the squirrel mail server. And then it'd be all run locally on the squirrel mail server. Would that secure down your email tremendously?
Well, it wouldn't prevent anybody from sending a Trojan attachment, though. I mean, you're not going to prevent email from getting delivered to the users. So they're running it, the attachment on their desktop.
Right.
Oh, the squirrel mail is still going to kick it back to the.
They're going to download the attachment,
Yes.
run it on their local machine.
Strip the attachment.
Well, then there
A lot
are
of companies
exchanges
do
to
that.
strip attachments, but it has to be smart enough to know what to strip, because you can't strip everything.
Yeah.
If you do business and somebody's sending you a
Yeah.
Word doc, you need that Word doc.
Right.
If the mail server strips it, you're out of business.
Or zip files, or, yeah.
Okay. From Carolina.
Anything else? All right, well, thanks for coming to the talk and.
Ladies and gentlemen, big thank you. That's fantastic. All right, it looks like we are